The first snickers were quiet, polite, the kind that came with coffee cups raised to lips and eyebrows lifting just a little too high. The European delegation had flown in from Zurich, Milan, and Rotterdam, veterans of steel and suspension, people whose bridges spanned icy rivers and ancient valleys. They stood in crisp shirts beneath the brutal heat of a Philippine afternoon, staring at the design board set up beside a muddy river in eastern Samar. It didn't look like a bridge worthy of an international conference. The renderings showed a lean, almost fragile structure, lower than expected, flexible where steel usually insisted on being rigid, with odd angles that seemed to defy the clean symmetry taught in European universities. Instead of massive concrete pylons, the supports appeared segmented, layered, almost woven. One of the Europeans chuckled before he could stop himself. "Is this temporary?" he asked. Maria Lanuza, the lead Filipino engineer, didn't answer immediately. She was used to this moment. The laugh before the question before the doubt before dismissal. "This is permanent," she said finally. "It's designed to last at least 100 years. That earned a few more smiles, tight, professional, indulgent. Someone muttered something about local optimism. Another whispered, in French, that it looked more like a bamboo experiment than real infrastructure. Maria let them talk. She had grown up 2 kilometers from that river. She knew how it behaved. How it swelled violently during typhoon season, how it carried tree trunks like toys, how it punished anything arrogant enough to challenge it head-on. European bridges were masterpieces of control, force balanced by force, steel refusing to bend. This bridge was not about control. It was about surrendering just enough to survive. The design came from years of quiet failure. Bridges washed away, concrete cracked, steel joints corroded by salt air and humidity no lab simulation could fully reproduce. After every storm, foreign consultants flew home, and local engineers were left with debris, angry communities, and the same question: why doesn't what works there work here? Maria and her team stopped trying to outmuscle nature. Instead, they watched it. They studied how coconut trees bent without breaking, how fishing nets survived waves by moving with them, how old Spanish-era structures that weren't optimized somehow still stood, their imperfections acting as shock absorbers. They designed joints that flexed microscopically, decks that allowed wind to pass through rather than fight it, foundations that spread force instead of concentrating it. It looked strange on a blueprint. It looked wrong to people trained to believe that stiffness meant strength. Construction finished just as monsoon season began. The Europeans had already left, filing polite reports that suggested interesting local concepts, but warned of long-term durability concerns. The bridge opened quietly. No ribbon cutting. Just villagers crossing, tricycles humming over the deck, kids leaning over railings to spit into the river below. 3 months later, the typhoon formed. It wasn't supposed to be historic. Storms rarely announced themselves as legends. It grew over warm water, tightened its spiral, and slammed into Samar with winds that howled like something alive and angry. Rain fell sideways. The river rose faster than anyone had seen. By midnight, evacuation centers were full. Power was gone. Radio reports spoke of landslides, uprooted trees and bridges, plural, collapsing inland. Maria didn't sleep. She sat by a small window, refreshing satellite images on her phone whenever the signal allowed, thinking about every compromise in the design, every argument she'd lost and won. She imagined the Europeans' laughter and wondered, not for the first time, if she had been wrong. At dawn, when the storm loosened its grip, the first drone footage came in. The river had swallowed its banks. Water churned brown and violent, carrying debris big enough to rip houses from foundations. Upstream, an older concrete bridge was gone. Nothing left but jagged ends like broken teeth. And there, in the middle of it all, was their bridge. It wasn't pristine. Debris had piled against it. The deck had dipped lower than normal, visibly flexing under the load. Railings were bent. The structure looked tired, almost bowed in exhaustion. But it stood. Wind pushed through it instead of against it. The segmented supports shifted, imperceptibly but decisively, releasing energy instead of hoarding it until failure. Where rigid structures upstream had snapped, this one had yielded just enough. Video of the bridge spread quickly. Engineers replayed it frame by frame. You could see it move. Not collapse. Not resist. Move. A week later, emails started arriving. From Zurich, Milan, Rotterdam. Short messages at first. Requests for data. Sensor readings. Construction details. Then longer ones. Invitations to present. To publish. To explain. One of the same engineers who had laughed wrote, "We believe we misunderstood what we were seeing." Maria read that line several times. Months later, she stood in a lecture hall in Berlin, presenting footage of the storm to an audience that sat in complete silence. No smirks, no whispers, just attention. When she explained the philosophy, not stronger but wiser, people nodded slowly like something heavy was settling into place. Afterward, a young engineer approached her. "They never taught us this," he said. "We were taught to dominate nature." Maria smiled, tired but proud. "In my country," she replied, "nature always wins. Our job is to make peace with it." The bridge in Samar still stands. It bears scars now, etched reminders of the storm that tried to take it, but villagers cross it every day, trusting something born from humility rather than ego. And somewhere in Europe, new bridges are being sketched with lines that bend just a little more than they used to. Years later, when the bridge became a case study rather than a curiosity, Maria returned to Samar during another storm season. The villagers no longer talked about typhoons with the same quiet fear. They spoke about preparation, about warnings, about crossing the river even when the water rose, trusting the structure that understood them. A European engineering journal eventually published a simple sentence in its review: "Strength is not always resistance." Maria clipped it out and folded it into her notebook. When the next typhoon came, and it did as it always would, the bridge moved again, breathing with the wind, bowing without breaking. And somewhere between the waves and the steel, the world had learned to listen. In quiet moments, Maria sometimes thought about those icy rivers and ancient valleys, places where stone remembered centuries and bridges stood defiant against cold and time. Those engineers had built monuments to endurance. She had built a conversation with the wind. Neither way was wrong. They were simply answers to different worlds. And perhaps that was the real lesson the typhoon left behind, that the future of engineering would not belong to the loudest steel or the tallest towers, but to those humble enough to learn where they stood, and brave enough to design for the land beneath their feet.